Hello everyone! Today I'm taking you inside the Higher Institute of Technological Studies of Sidi Bouzid for an immersive look at a high-level technical workshop, the art and science of superfatty soap making. This event was organized by the Center of Excellence in Food Processing in close collaboration with the Agro-Process and Green Tech clubs. It brought together passionate community, including technicians from the chemical engineering department, as well as our undergraduate and professional master's students. Cold process soap making has definitely taken off in the world of cosmetics. Here we take a look at the fabrication process of an authentic Surgras soap. Soap is a product resulting from a chemical reaction called saponification between the molecules of a fatty substance and a strong alkaline agent. It acts as a surfactant, meaning it can bind both with water and fatty substances, which cannot normally bind on their own. Saponification is a chemical reaction provoked by mixing a fat, oils, or butters with a strong base. For solid soap, the strong base is sodium hydroxide lye. For liquid soap, the strong base is potassium hydroxide, also known as potash. This reaction creates two elements, glycerin and soap. A cold process soap is ready the moment all the lye has been chemically transformed, and there is none of it left. In order for all the lye to be transformed into soap, the oils or butters are used in excess to be sure that all the lye is transformed. The leftover fatty acid is what we call Surgras. Surgras is known for its nourishing, softening, and protecting the skin. A Surgras soap is a soap in which the oil or butter has been dosed so as not to be entirely saponified by the lye. The purpose of this superfattening is to enrich the soap with the natural properties of the vegetable oils, making it a more gentle product for sensitive skin. The workshop began with an in-depth theoretical presentation led by two of our expert colleagues, Dr. Manel Boudabous and Dr. Nisreen Ghanem. They covered the saponification mechanism, additive selection, and the use of soap calculators to ensure perfectly balanced formulations. They give us an example of a digital tool to formulate precise, balanced, and safe recipes. Then they presented the difference between lye reduction and adding oils at the end of the process. Sodium hydroxide, also known as lye or caustic soda, is a strong alkaline compound that is used as a base in the saponification process, which is the chemical reaction that turns oil and fats into soap. Sodium hydroxide appears as a white, odorless solid that is highly soluble in water. While it's a powerful and potentially hazardous substance, in the world of soap making, it's essential. It's important to know that sodium hydroxide in its raw form is high corrosive and can cause severe skin burns or eye damage if mishandled. However, once it undergoes the saponification process with oils, it transforms into soap and glycerin, which are safe for use on the skin. Sodium hydroxide is the main chemical agent in the saponification process, the reaction that creates soap. Here's how it works. Soap is made by combining fats or oils with sodium hydroxide. The sodium hydroxide breaks down the fats, which are typically triglycerides, into their compounds, glycerin and fatty acids. The fatty acids then bond with the sodium hydroxide, Which are the molecules that makes up soap? The general equation for the saponification process looks like this. After the saponification process, the result is soap and glycerin. Glycerin is a humectant, meaning it attracts moisture to the skin, which helps keep the skin hydrated. The amount of sodium hydroxide used in soap making is calculated based on the oils being used. If too much lye is added, the soap can be harsh and drying to the skin. If too little is added, the soap will be oily and will not harden properly. This is why accurate measurements and a balanced lye-to-oil ratio are so important. Now, time for action. Participants were divided into groups in a fully equipped laboratory. In the lab, safety was our top priority. All participants wore lab coats, gloves, and masks. Everyone handled the reagents with precision under the fume hood to ensure optimal ventilation. Each station was fully equipped with beakers, spatulas, thermometers, heating plates, precision scales, and stick blenders. The process followed strict technical steps. We explored two specific methods: superfatting by addition. The second technique is lye reduction, calculating a discount in sodium hydroxide. First of all, we heat the oils and prepare the lye solution while monitoring temperatures. Measure out with total accuracy your sodium hydroxide according to your recipe, with the exact amount of water. Make sure you do not use hard water in cold process soap making, as the unwanted chemicals in the water could react and ruin your soap. We recommend the use of distilled water. Once you are ready with the exact amount of lye and water, warm the olive oil slowly in another beaker to reach 45 to 50 degrees Celsius. As soon as both oil and lye solution are at the same temperature, add the lye solution to the oil, and the two are blended together with a stick blender to initiate saponification. Water is measured, then the lye added, never the other way around. This mixture will generate heat and release fumes, so it should be done in a well-ventilated area while wearing proper safety gear. The main indicator to know that the oils and lye are reacting with one another is the trace left by the mixture. As the oils and lye begin to emulsify, the trace will appear in about 5 minutes of mixing. Alternate between pulsing your stick blender and using it to stir for about 10 to 15 minutes. So, switch between short pulses and stirring with the blender until the mixture come together to a light trace. Some groups of participants chose superfatting by adding essential oils for their aromatic and therapeutic benefits. In our case, we've used coconut oil and apricot kernel oil. Others practices lye reduction with the addition of coffee grounds, creating a natural, eco-friendly exfoliating soap. To finalize the process, the soap was poured into molds and carefully covered with plastic wrap to prevent air contact and soda ash formation. Now, we wait 24 to 48 hours before unmolding, followed by a curing period to ensure the soap is mild and durable. Cold process soap making is a manufacturing process that, as the name suggests, does not involve heating the ingredients. Non-industrializable, this process also differs from hot process soap making because it must be made in small batches and must cure. The curing time should be respected before the soap can be used. Cold process soap making is quite long. Once the mixture has been poured in a mold, the soap must be cured. This drying process is typically a minimum of 4 weeks. This allows the saponification to completely finish and the soap to dry. The environmental impact is reduced when practicing cold process soap making due to the fact that there is no heating period. This process therefore requires very little energy. This ancestral technique requires time and patience. Cold process soap making is also something you can do yourself. Just be sure to follow the recipe, use the correct measurements, and handle the lye with caution. The rest is left up to you. Play around with your creative side. Add plant or mineral-based dyes to color your soap. Use essential oils for their natural benefits and fragrance. This workshop was a total success, blending theoretical expertise with hands-on craftsmanship. This successful workshop would not have been possible without the dedication of our team. We would like to extend our deepest gratitude to our expert animators. A huge thank you to the two doctors, Madame Manel Boudabous and Madame Nisreen Ghanem, for sharing their profound knowledge and guiding us through the complexities of saponification. A gratitude to the Center of Excellence in Food Processing and the Agro-Process and Green Tech Clubs for their flawless organization. And finally, a special thank you to our technicians for their vital role in preparing the laboratory and ensuring everything runs smoothly. Thank you all for watching. Together, we are building a bridge between science and sustainable innovation. Don't forget to subscribe to stay updated on the latest innovations at ISET Sidi Bouzid. See you in the next video.